with respect to the particular slides, kindly intimate me as I rightly intimated by your HOD, Dr. Krishnan sir. Danny will take care of it. So I congratulate the PG Department and Research Department of Commerce and Management Studies for organizing this 2-day seminar. And I am also happy to know that Ms. Sumani is also one of the faculty members of this prestigious institution. She will be really a resourceful teacher in the Department of Commerce. And I congratulate all the research scholars who have taken part and who are taken to be the instruments and catalyst of organizing the seminar, especially Danny, the research scholar. Danny's father is my friend. We were colleagues in Fatima National College, joined on the very same day. We were for more than 20-25 years together. Anyhow, congratulations. So let me move on to the presentation. I am offing my video. Okay. I think the slide is visible. Can you see the slide sampling?
Yes, yes, sir.
Yes, sir.
You can see the second slide also. Theoretical
Yes,
basis.
yes,
Okay.
yes.
Yes, very good. So as I requested earlier, please intimate me whenever there is any problem with the slides. So we all know that commerce and management are the two broader subjects that will come under social science. So in social science, we can carry out the research work by using sampling method. That means we are unable to make use of the population, or we are unable to make use of the census study, as the population is very large, maybe scattered, maybe spread around different parts of the nation or state or study area, which may be very difficult to collect data from each and every members of the universe. Therefore, in social science, it is justified that sampling study can be applied. And the sampling study can be applied on the basis of the principle of probability. We know that there are different concepts of probability, different types of probability, wherein one of the types tells us that relative frequency approach of probability. It tells us that if we carry out a particular investigation or activity for a very large number of times, more number of times, then the results will be stabilized. The variation or fluctuation, the outcome or results will be stabilized, which tell us that we need not again continue with more number of members, but we can come to the inference if we have taken a large number of samples. That is the inference or the conclusion which we reach from the sample study will be applicable to the population also, provided we take large number of samples. Can you use this slide, theoretical base of sampling?
Yes,
Yes,
sir.
sir.
Okay, yes. So the fundamental basic principle that we have to understood before we apply or make use of the sampling technique in research work, one is called law of statistical regularity. So this law tells us that if we are selecting a part of the population selected from the universe, or the census is called a sample. It's a group, it's a division of the population. So if the sample so selected is on an average will have the very same properties, features, characteristics, and essentialities of the universe. That means once we have selected some portion of the population or universe, that portion selected will have all the same characteristics or features or properties or composition of the population it belongs to. This rule is called law of statistical regularity. And not only, there is another important theoretical base or fundamental principle of sampling tell us that if the number of samples we selected is large, then there will be more reliability of the answer of the population. You know that if a population is represented by a single value, that single value which represents the population is called a population parameter. Say a population parameter may be represented by population mean mu, or may be represented by population's standard deviation sigma, or maybe population proportion capital P, or maybe correlation coefficient R. So that particular population may be represented by an individual value that will be representing the entire population. That value so representing the universe or population is called as population parameter. At the same time, as we are considering or selecting only a part of the items from the population as sample, this sample can also be represented by a single value. For example, if you are taking the, say, 15 research scholars who are attending this class, and their, say, average time spent for listening or attending the particular workshop can be assessed. So when we make use of different values to represent the sample we selected, they are called as a sample statistic. The different sample statistic which will be representing the sample may be, say, sample mean x bar or arithmetic mean, or sample standard deviation, or sample proportion small p, or sample correlation coefficient. So population is represented by one value called population parameter. Sample is represented by one value called sample statistic. So in a study of sampling, we are confronted with an issue as to what extent this population parameter represents the sample statistic or vice versa. Or is there any difference between the population parameter and sample statistic? More the difference between the population parameter and sample statistic means what the inference or conclusion we reach from the sample study may not be applicable to the population. Therefore, it will be better to have larger number of sample size so as to reduce or minimize the difference between the population parameter and sample statistics. So law of inertia of large number denotes this. So law of inertia of large number tells us that if we are selecting a larger sample sizes, then the difference between the population parameter and the sample statistic will be less, means the result or the inference or conclusion which we come across from the sample study will be more or less same as that of the population from which the sample is being selected. So these two are the fundamental theoretical base of the entire sampling theory in social science. So we have to have a decision as to whether a census study is to be conducted or a sample study is to be conducted. Even though in social science it is justifiable that a sample study will be representing the population, it will be better to have the census study. Why? Because the accuracy or the reliability or the correctness or the genuineness of the inference or the conclusion we reach from the sample study will be 100 percentage. Sorry, census study will be 100 percentage. On the other hand, if we are using sample study, we cannot ensure 100% accuracy or correctness of the result. Therefore, there is a problem as to whether a census study is to be adopted or a sample study is to be adopted. This cannot be easily answered. This will be answered by means of considering number of factors. So one of the important factors which we have to consider to take a decision as to whether to make a census study or sample study is field of inquiry. Another one is availability of resources. And another one is degree of accuracy expected. And the next one is called the size of population. So the field of inquiry means if we are making an investigation or research work or scientific study in a broader area, in a larger area, and that area is scattered, spread over the entire area of the research work, we may find it very difficult to travel and collect the memories, each and every elements of the population from the different areas. But if the study area is limited, not scattered, then it may be possible to carry out the work on a census study. Therefore, the field of inquiry is considered as one of the important factors that will help us to see whether to follow a census study or a sample study. Another important factor is the availability of resources. So if more resources are required to carry out the census study, more money is needed, more persons are needed, more time is needed, more say what the different physical, financial, technical or human resources are required to carry out a census study or a population study. But in comparison to the sample study, we can find that census study needs more resources, more human resources, more technical resources, more time, more efforts, more technical application. But in sample study, comparatively, the resource requirements are less. And the another very, very important factor that is to be considered is what is the degree of accuracy we expected. When we carry out the investigation, when we carry out the research work, what is the accuracy, what is the correctness, or what is the genuineness, or what is the promptness of the result we expect. If we are expecting 100% promptness, there is no other go other than census study. But if we are making certain compromises as to the 10% correctness or promptness or genuineness, then we can follow sample study, as it is justified in social science that sample study result will also be the very same. How we can say that the sample study result will also be the same? See, as per the probability principle, as I mentioned earlier, relative frequency of probability, or relative theory of probability. Say, for example, if you are tossing a coin for larger number of times, the probability of getting the head will be stabilized or it will be 0.5. For example, if you are tossing the coin for 10 times, the ideal situation is that we have to get 5 heads and 5 tails. But really, when we are tossing the coin, which may not take place. If we repeat the trial for 100 times, the ideal situation is 50 heads and 50 tails, but may not take place. But if you are continuing this trials or tossing your coin for quite large number of times, say 300 times or 400 times or 500 times, then we can find that the probability of getting that outcome head will be remaining as 0.5 when the number of trials is 300 or 400 or say 500. It means even though we are repeating the trials for up to 1000 times, there will not have any difference in the probability of getting the head. That means the probability of getting the outcome is stabilized, means whatever be the result we obtain on account of carrying out a study by taking larger number of samples, it will have the very same result of the population. And if the population size is to be considered, this is also very, very important. That is, to whether we have to apply a sample study or census study will be decided by the size of the population also. If the population is small, say 1000 is a population, or say 500 is a population, then it can have the population study. But if that population is definite, then only we may be able to adopt the sample study. That means if the population is infinite, we are not able to name or identify or locate each and every members of the population, then we cannot apply sampling method. So sample study can be applied only when the population is finite, the population is known, the population can be identified. If the population is infinite, if we cannot locate or pinpoint or identify the particular items of the population, we cannot carry out the sample study. Therefore, one of the basic understandings that we need to have is that we can apply the sample study only when the population is finite, the population is definite, and we can pinpoint or define or locate or identify each and every element of the population. Can you this slide see the slide steps in sampling? I'm not sure, that's why I'm asking you.
Yes, sir. Yes, sir.
Yes, okay. So another important step that we need to understand is, or another important say point that we have to keep in mind is, if we are going to apply sampling method in conducting the study, what are the steps involved in sampling? There are different say procedures, step 1 2 3, like the iterative step will be there. So the different steps involved in sampling are, one is define the objectives of the investigation. What is the objective of the investigation? If you are not able to define the objective of the investigation, we cannot take a decision as to whether we can follow the sampling method or not. Then second one is define the population. What is the population? Say here the population of this particular seminar is the research scholars who are going to attend the coursework examination in commerce of the University of Kerala. So this is the population. Are we able to define? Are we able to mention each and every item of the population? So definition or identifying or pinpointing the elements or members of the population is another important step. If you are not able to identify the elements or members or constituents of the population, we cannot apply the sample study. And another important step is that specify the sampling units. What is meant by sampling unit? Sampling units represents the respondents from whom the data are to be collected. That is a mistake, data is recorded there. So sampling units are the persons or individuals or agencies or institutions or organizations where from we are expected to gather the data for making the investigation. So that particular sample units may be organizations, it may be regions, it may be cities, it may be a house, it may be an individual, it may be a club, it may be a school, it may be a family, or It may be any unit or any organization or agency from which the respondent, the investigator, can collect the data. The persons or individuals or institutions or agencies from whom we have to collect the data for carrying out the study is called the sampling unit. So here in this case, particular workshop oriented for the coursework examination, sample unit refers to each and every students who participate this workshop. They are the persons from whom we have to get the response as to how effective was the two-day seminar. So another important factor is deciding the sampling frame. See, sampling frame means get a list of the sample units. Say, for example, if 50 students are attending this workshop, getting the list, name and address and other details of the members who attend the seminar can be defined as the list of the samples. And this list of samples can be defined as the sample frame. Then another important factor is determine the sample size. So the sample size selected should not be too high or maybe too less. If the sample selected is too high, it may require more resources, more financial, physical, or human or technical resources are needed. And not only that, that may give the very same result as of the sample study also. And another important factor is that if you are selecting a very lower sample size, the sample size selected is not adequate enough to reach a conclusion about the population, then the study will not give any outcome, or the outcome or the result obtained may not be applicable to the population it belongs to. Therefore, ideal determination of the sample size. Determination of the ideal sample size for conducting the investigation is also another important step to be addressed before we plan the sampling technique. And another important one is availability of funds to conduct the investigation. Some agencies or sponsoring agencies or institutions are providing the fund for carrying out an investigation. What about the funds available for conducting the research work or investigation is another important factor. And again, another important one is which is the sampling technique to be adopted so as to reduce the sampling error. See, the error means here the sample error means the difference between the population parameter and the sample statistic. Whether the sample statistic and the population parameter are the same or not. If the difference is there, if there is difference between this population parameter and sample statistic, we would say that there is sample error, and our intention should be to reduce or minimize the difference between the population parameter and sample statistic. That means there should be difference, lower difference between the population parameter and sample statistic, and the method we are selecting for the sample selection should be ideal one. If you are selected a proper ideal scientific sampling technique, then we may be able to reduce or minimize the sample error. But if the methodology we are selected for the sampling is not ideal or proper, that may not help us to reduce the sample error. And the last step involved in the sampling technique is you collect the data, gather the data from the respondents, you enter the data, process the data, make the tools or apply the devices for making some inferences and present the result. So the various steps involved in the sampling technique are definition of the objectives of the investigation, definition of the population, specifying the sampling units, deciding the sampling frame, determining the ideal sample size, and determining what about the fund available for investigation, and deciding as to which sampling technique is to be used, and we can proceed further. And these are the important steps involved in sampling technique. So the selection of ideal sampling technique will be helping the investigator to reduce the sample error. Whenever we carry out the sample study, our objective should be the difference between the population parameter and sample status should be the lowest or the minimum or the least one. And this lowest difference between these two values can be ensured by means of having lower sample error. And this sample error can be reduced by means of selecting an appropriate sampling technique. So there are two important sampling techniques for selection of the sample. One is called probability sampling or random sampling. The other one is called non-random sampling or non-probability sampling. So between these two sampling techniques, the investigator, the researcher has to have an understanding as to what are the different probability sampling methods. How can we select each of the sample under the probability sampling methods? Or what are the different non-probability sampling techniques, and how can we select the sample under these non-probability sampling methods? So let us see what are the important probability sampling methods or techniques. So probability sampling techniques. I think the slide is visible to you.
Yes,
There
sir.
are okay.
Yes, sir,
So
it's visible.
okay. So the different sampling techniques coming under the probability technique are: one, simple random sampling; two, systematic sampling; three, stratified random sampling; four, cluster sampling; five, multi-stage sampling. But the real problem in carrying out the research work is that we used to say that we are adopting probability sampling method. Also name this is the probability sampling method we adopted for gathering the data. But whenever we are asking a question as to how did you identify the sample, how do you select a particular sample, then there will be a problem as to how it is being selected. So we need to have a clarity in the theoretical concept of each of the probability sampling method. See the first one, simple random sampling method. We all the students or the research scholars or researchers are having a misunderstanding that this is the most simplest probability sampling method. No, this is not at all simplex. This is a complicated, complex probability sampling method. And the essentials that we have to ensure to apply simple random sampling is that: one, the population should be definite. That means you need to have a ready-made list of the respondents or the members or the elements or constituents or the whole items of the sample should be definite. If you are not having a definite list of each and every item of the population or some or the universe, we cannot apply simple random sampling method. And peculiarity of the simple random sampling method is that every members or every elements, or we may say that every sampling unit of the population has equal chance of being selected. If 1000 elements are there in a population, and that is definite and that can be listed, then the probability of selecting one item from this 1000 population item is 1 divided by 1000. So equal probability chance is therefore selection of all the items of the population. That is the another important peculiarity of this simple random technique. And again, you ensure that we are not having our own biases. We are not having any preferences. We are scientifically selecting the sample unit, not by the personal bias or not by the personal interest of the investigator or researcher. Then a real question arises as to how do we select the sample under the simple random sampling method? So there are broadly two methods used for selecting random under the simple random sampling. Under probability random sampling method or probability sampling method, we can adopt or select the samples under simple random methods by following any of these two methods. One is called lottery method, other is called table of random numbers method. Then how can we select the sample under lottery method? See, if the number of items of the population is small or definite, say it's 1000 or say 500 or 300, it is definite. We can list out or identify each of the particular elements or members of the population. So all these items can be numbered. It can be serially numbered or can be named in separate sheets of papers. And these sheets of paper should be of same size, identical size, shape, or color. Means if 1000 members are there, you make 1000 same size or shape or color of sheets of papers, make a number or the name in each of these 1000 sheets. Sheet 1, 2, 3 up to 10 up to 1000. Then you fold it, put it in a container, then you shake it and you take the slips one by one. So whenever we are able to define or list out or name or identify by a serial number or by allotting a name, enter the same in a slip of paper of same size, same color, and say what is called same shape. Then fold them, put them in a bowl, shake them, then select one by one. If one out of 1000 population, if we intend to select say 100 units, you can select the first one. Read the number. Suppose the first sheet of paper selected is bearing the number 15. Now we have already identified who is the member in the population bearing the name or number of 15. We can collect data from that particular respondent or sample. So in this way, we can select all the samples from the particular box or container which contains the entire units of the population. And this particular type of lottery method cannot be employed if the population is very large. It may be quite difficult to list the name or number of each of these elements and put it them, fold it them, check, and again take out of this particular box, maybe leading to have, say, more issues, it requires more time. So if the size of the population is larger, we can apply what is called a table of random numbers method. So several standard tables of random numbers are available. There are different types of tables of random numbers. So one is called Tippett's random numbers table. Another one is called Fisher and Yates random number table. Another one is called Kendall and B.B. Smith random number tables. Another one is there C.R. Rao's random number tables. So there are different types of random numbers which are available in the computers, and of these random numbers you can select any one random number table of your preference or choice. Then we can make use of that particular random number tables for selection of the items. So how can we make use of the random number tables for selecting the samples? Here also, what is expected is each item of the population is to be assigned with a number. For example, if 50 students are attending this seminar, we are giving an identification number 1, 2, 3 up to 50. Now, we are identified or listed the elements of the population, and these numbers will be read out. Say, for example, if a table is made use of, the random number table is made use of, which contains, say, random numbers of 3 digits, 5 digits, 4 digits, like that, different digit random numbers are available. Say, take an example. Suppose we have, say, a 5,000 population item is there. 5,000 is the items of the population, and we have to select an item sample of 100. 100 sample is to be selected from 5,000 population. So most important thing is we have to identify each of these numbers or members, that is from 1 to 5,000. This may be the employees, this may be the customers, or this may be the organizations. It may be starting from south to north, or maybe starting from, say, north to south, or maybe starting from the designation, like that. Whatever be, if 5,000 respondents or population members are there, we should be able to distinguish each of these 5,000 items. Otherwise, we cannot select a particular sample of 100 items according to the simple random method. So if 5,000 items is there, our step is 5,000 has 4 digits. Is it? Do you follow me? I'm not getting any
Yes, sir.
response.
Yes, sir.
Yes, sir.
So if, okay, so if 5,000 items are there, members are there, in 5,000 there are 4 digits. Therefore, we can select a random number of 4 digits. Suppose we are starting from the random number table from any point of your choice. These random numbers are given in rows and columns. From any point, you can select a random number. Suppose the number obtained is 3,100. As it is less than the total number of population of 5,000, this number bearing, random number bearing 3,100 can be selected as the first sample. Now, we have already identified who is the respondent having the number 3,100. So we can select that particular individual respondent as the first sample for collecting the data. So in this way, we are selecting 100 numbers. Suppose we are getting a very same number already selected, drop it out, take another one. Suppose in the 4-digit number itself, we obtained a value, say 6,000. We obtained the random number bearing 6,000. Now, we cannot take 6,000. Why? Because our members are only 5,000. So what we can do is, from this random number 6,000, you deduct 5,000, balance is 1,000. So you can select that particular item considering that 1,000 as an item of sample. So in this way, we may be able to take all the 100 items of sample from this 5,000 members of the population. So this is the real systematic method of selecting sample under simple random sampling. That is why I told you earlier that we can follow the probability sampling method, especially we can follow the simple random sampling method only when the population is definite, only when we are able to identify or say distinguish, give a number or identification mark or name to each and every member of the population, then only we may be able to apply this particular simple random sampling method. So the simple random method is considered as the most important probability sampling method, wherein we are collecting the respondents without any bias of the investigator, systematically, scientifically, on the basis of the probability, chance alone, we are collecting or we are selecting the respondents for collecting the data. And the second important method is coming under the probability sampling method is, say, systematic sampling. What is systematic sampling? So we need to have idea as to what is the whole population. So if we don't have any ideas to the population, we cannot apply probability method that I already mentioned. Again, we need to estimate what is the sample size based on the error or based on some other parameters that will be seen. Based on the parameters, we may be able to estimate the sample size also. So in the earlier problems, which I have got as the example, the population size is 5,000 and the sample size determined is 100. We will be selecting only the first sample under probability sampling method. So the difficulties, much difficulties associated with the simple random sampling method can be eliminated. Here in this case, only the first one will be taken on random sampling method. That means you divide the population with the sample, 5,000 divided by 100. So we are getting an interval. That interval is called fixed interval. The sample, so we obtained is called fixed interval sampling. And that sampling, fixed interval sample is represented by K, capital N divided by small n. That means population size divided by sample size. 5,000 divided by 50. 5,000 divided by 100. So interval equals 50. So then the next step is either we can select a random number bearing 50 or we can select a random number less than 50. So from random number 1 to 50, you can select any random number from the random number table. Select the first one. Suppose we have taken the first out of 50, interval 50, we are selected the 39th random number. So we have selected the 39th number. First sample selected is 39th. Next sample will be selected by keeping the fixed interval of the sample. That means 39 plus 50. Select the random number with 139. That means here we can select the population bearing the identification number 139. Again, you add the fixed interval 50. Say first 39, then 50, 89. Again, you add 50, 139. Select the sample. Again, you add 50, 189. So in this way, by keeping that fixed interval, we may be able to select the sample item from the population. Why? Because we were able to identify or locate or number or distinguish each of the 5,000 items of the population. First, we are taken 39. That is up to you to decide. You can select. We need not make use of the random number table anymore. As we have given the number to the populations, first we have determined the fixed interval, then keep that interval. Select any of the item from the population having less than 50. You need not select the random number, but you can select any of the population item bearing the number 50 or less than 50. Suppose you can take 40. First, suppose you select the item bearing 40 as the sample. Then you select the next item, 40 plus 50, 90. Select the population bearing the number 90. Again, you add 50, 90 plus 50, 140. Select the population bearing the number 140. So in this way, the difficulties associated with the simple random method can be overcome. Also, we can ensure that this is a probability sampling method also. This is called the second one, systematic sampling. So in systematic sampling, we are concerned with what is called a fixed interval. So two things are essential here. Population should be definite, sample should be estimated. And population definitely means we are able to list out or name or identify or distinguish each of one can be picked from 5,000. Why? Because it is being identified. So that is a second important method, systematic sampling. I think you follow me. Do you follow me?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So the next one, the third important probability method of sampling is that, say, stratified sampling. And the stratified sampling will be applied in situations wherein the data or the population or the elements is not homogeneous. The population is said to be homogeneous if all the properties or features or characteristics of the members of that group remain the same. Now, all the students, research scholars who attend this 2-day orientation can be considered as homogeneous. Why? Because all of you are attend the examination, coursework examination. So we may call it as a homogeneous group. And again, we can find that if we go in depth, we can find that this all the research scholars who are attending this particular orientation is not homogeneous. They are heterogeneous. How they are heterogeneous? There may be girls, there may be boys, there may be students who are doing research in SD College, or say at Marvanius College, or the Department of Commerce. There may be students who are availing JRF or NET or PhD entrance examination like that. So there can be, say, different features of the members of the whole population. So if the population of the particular study is heterogeneous, not homogeneous, they are distinct, then it will be better to divide that particular population into different groups based on the same characteristics or features or properties. And all those items having the same properties, same characteristics, put as one strata. All the research scholars who are attending this orientation program, working in government colleges, one strata. All the research scholars attending this orientation, working in aided college, another group. All the research scholars having JRF, make another group. All the research scholars having net, another group. So in this way, we are stratifying, we are dividing, we are grouping the entire population into different group or different strata. Each such a strata is called a stratum. So how many stratum should be there? If in a population, if you are classified into 5 strata, 5 groups, how many strata are to be there? And how many items are to be selected from each strata? As I told you, government college teachers, aided college teachers, JRF fellows, net fellows. See, four stratum. So four strata are there. So how many items are to be selected from each stratum? How many teachers from government colleges, from aided colleges? How many students of JRF? How many of net? In this way, we are classifying the entire population on the basis of resemblances or similarities. We may say that is stratum. And this stratified sampling is sometimes called as, say, complex probability sampling method, complex or mixed probability sampling method, because the first step of stratification, grouping or dividing the entire population different groups depends on the bias or interest of the investigator or the researcher. So there an inconvenient or there a non-probability method is being applied, and after that we are selecting the sample under probability method. Therefore this method is called say mixed, say random sampling method, mixed probability method or complex probability method, because it includes both probability method and non-probability method. First we are applying non-probability method for making the stratification, then second we are applying the probability method for selecting the sample items from each stratum. So how many items are to be selected from these four groups is of paramount importance. Number of items to be selected from each stratum can be done under two methods. One is called proportionate sampling method. Second is called disproportionate sampling method. So under stratified random sampling, we can determine the number of items to be selected under two methods. One is called a proportionate random sampling method, another is called a non-proportionate or disproportionate random sampling method. Suppose we are given this example. Say, take the example of a proportionate random sampling. How can we select the samples from each stratum under proportionate random sampling method? Suppose we found that the population size is 8,000, and by applying an equation, we determine the sample size as 30. So population size capital N is 8,000, sample size is small n equals 30. And as I told you, in the stratified random sampling, we are stratified or group the whole population into three strata. Strata 1, strata 2, and strata 3. And suppose we found that out of his 8,000, 4,000 members or elements are there in strata 1, 2,400 in strata 2, and 1,600 in strata 3. Now, how many items are to be selected from each strata under proportionate random sampling equals the population size of each strata divided by total population into total sample size. Population size of each strata divided by total sample size into total population into sample size. Say the first one, total population is 4,000 divided by total population of the all strata is 8,000 into total sample size 30. 4,000 divided by 8,000 30 equals 15. 15 is the number of items to be selected from the first stratum. See the second stratum, 2,400 is a population. That 2,400 divided by total population 8,000 into total sample size 30. So it equals 9. And third stratum, the population is 1,300 and the total population is 8,000. Therefore, the sample size to be selected from this stratum will be, see, its population 1,600 divided by total population 8,030, that is 6. Altogether, you see 15 plus 9 plus 6. Then, how can we select the sample items under probability method? how can we select the sample items under probability method. So this is very, very important, but in none of the research work this type of identification of the sample is not being done. The calculation may be shown, but sample are not taken a true spirit. Then how can we take the 15 items under probability method? Or how can we select the 9 items under probability method, or 6 items under probability method? So first, stratum 1, we have the elements of 4000. We have numbered all the elements into 1 to 4000, and from which we found that 15 is the sample size required. You determine the, say, fixed interval, that is 4000 divided by 15, that equals 267th item. So from the first stratum consisting of 4000 population, as were identified or located as 1 to 4000, you select the 267th item. Then you add again 267 with this. You need not select 267th item. You can select any item below this 267th item. You can select, say, item 100. Suppose you are selecting the item bearing the number 100 from the first stratum, then you have to select the next item as the sample 100 plus 267, that is 367. This population of the stratum having the number 367 will be selected as the next sample. Again, the next sample will be this 367 plus 267, like that. So like that we can select 15 items. In the second situation also, the second stratum also, as we have numbered distinctly 2400 from 1 to 2400, then you divide that particular 2400 by the sample size expected, that is 2400 divided by 9. Take the number of items, select that particular number from the second stratum, then add the interval and accordingly select 9. And the third stratum, say total population is 1600, that is been defined, that is numbered 1 2 up to 1300, and the sample size required from the third stratum is 6. So 1600 divided by 6, get that interval, select that item from the third interval, again third stratum, again add this interval. In this way we can select the sample item. So this is the real true way of selecting samples under stratified random sampling. Make the stratification, define the population, number them, make the fixed interval system, then select the samples required under each category, and you take the total 15 plus 9 plus 6, that equals 30 size. I think it is clear to you. If you have any doubts, you can get it clarified. Do you follow me? I'm not getting a response.
Yes, sir. Yes,
Yes,
sir.
sir.
Okay. So under random sampling method, we stratify the random sampling method. If we follow the proportionate random sampling method, divide the whole population different stratum, that stratification is up to the investigator. There may be non-probability. Probability sampling cannot be applied there. It is on the basis of the requirements or prioritization or preference or bias of the investigator. We may group into 3 categories. If we are classified into 3 categories, list the population of each category, identify them, locate them by number or name. Then in this way you can select the sample. And as I told you that under stratified random sampling method, we may select the sample under disproportionate sampling method also. Disproportionate sampling method. So if you are not following the proportionate sampling method and disproportionate sampling method is being followed, we are computing the sample size in a different way. So if we consider that the total population is divided into 3 categories, that is first stratum 5000, second stratum 2000, third stratum 3000. And in the disproportionate sampling, we need to have the understanding of the standard deviation of each of the stratum. Standard deviation of first stratum, second stratum, third stratum should also be known. Therefore, disproportionate sampling method can be applied only when you are computing the standard deviation of each stratum also. Once we obtain the standard deviation besides the population of each stratum, then we can adopt the disproportionate sampling method if we estimated the sample size also. So by adopting the formula, what will be the formula that we can see later on if time permits. Sample size is 84. Suppose sample size estimated is 84. Then how many sample items are to be selected from this first stratum? 5,000. If the total sample expected is 84, first population sample is 5,000 and its standard deviation is 15, then the number of samples of item to be selected from the first stratum should be total sample into first population into, say, that particular standard deviation 15 divided by product of the total of population size and standard deviation. That means from the first stratum, the sample size to be selected will be total sample record 84 into, say, the sample size of the first stratum 5,000 into its standard deviation 15 divided by total of, that is 5,000 into 15 plus 2,000 to 18 plus 3,000 to 5. It is similar as that of, you might have studied Bayesian theory of probability. It is similar as that of Bayesian theory of probability. So accordingly, out of 84, we have to select 50 samples from the first group. From the second group, how many we can select? Say the sample size 84 into second size population 2000 into second size standard deviation divided by total, that is 5,000 to 15 plus 2,000 to 18 plus 3,000 to 5. If time permits and if you have the paper and book, you can take down this. And accordingly, it is 24. And the number of samples to be selected from the third stratum is equivalent to total sample record 84 into third sample population strata 3,000 into its standard deviation 5 divided by total, that is 5,000 to 15 plus 2,000 to 18 plus 3,000 to 5. Accordingly, it is 10. Take the total, it is 84. Then how can we select it? So how can we select 50 from the first sample? As we are seen already that from the first stratum 5,000 is there. The sample record is 50. Therefore, under the systematic sampling method, say select the interval, find the fixed interval, that is 5,000 divided by 50. So that is 100. So as we have identified the first stratum 1 to 5,000, there is an item 100, there is an item 1, like from 1 to 5,000 items are there. Select first item, say 100, need not take 100, you can take 90th item. So see, if you are selected item bearing the number 90 from first stratum, then you add 50. So 90 plus 50, 140. Select the sample bearing the population, the first stratum 140. Again add 50, that is 190. In this way, you can select the entire 50 samples from the first stratum, and similarly in the second stratum, like that we can select the different days. Just please wait for 1 second. I am receiving 4 or 5 mobiles from the space in number.
Okay, sir.
Hello? Hello? ഹലോ ഐ മീൻ ഞാൻ ഒരു മീറ്റിംഗിലാണ്. ഞങ്ങൾ വിളിച്ചപ്പോൾ 3-4 പ്രാവശ്യം കട്ട് ചെയ്യേണ്ട കാര്യം അതിനെ മീറ്റിംഗ്. ഓക്കെ, കോൾ മീ ആഫ്റ്റർ 4 p.m. Hello? Yes, can you hear me?
Yes. Yes, sir. Yes,
Yes.
sir.
So this is the disproportionate sampling. So between proportionate sampling method and disproportionate sampling method, which method we can prefer? So the first method can be preferred. Why? Because we need not compute the standard deviation for each stratum. Just the population of each stratum is essential. But to follow the disproportionate sampling method, we have to have the figure of standard deviation of each stratum. By considering that standard deviation also, we are taking this. So that are the two methods which can be followed under stratified random sampling method. One is called say proportionate sampling method. Second is called disproportionate sampling method. And the next method is fourth probability sampling method is cluster sampling. So the different probability sampling methods we have seen. First one was simple random sampling. Second, systematic sampling. Then third, we have seen stratified random sampling. Now the fourth one, cluster sampling. Cluster sampling is also a complex sampling because how do we find out a cluster is a matter of personal preference or personal bias. So this cluster sampling is applied whenever we don't have a complete list of the population. When the investigator or the researcher does not have the complete list of population, we can adopt cluster sampling. Say, for example, we have to find out the clusters of scheduled caste or scheduled tribe, or say what is called people belong to BPL or people belong to Adivasis. So there may be a group or cluster having the very same properties or very same characteristics. At the same time, we are not able to get the list of all the items of the clusters coming under the population. We cannot get the entire list of the clusters coming under population. Therefore, what we can do is you identify or define the cluster. Say cluster, say for example, cluster of Adivasis, cluster of scheduled tribes, say a cluster of colleges, a cluster of say hotels, a cluster of schools, a cluster of say factories or manufacturing factories, like that. So when we don't have the complete list of the population, we can classify or we can group the whole population into different clusters. Each cluster will have a focus or a concentration of a particular group. Say for example, as I told you, Adivasis or tribes or cluster colleges, like that. So take that particular cluster. So from that different clusters we have identified, we should be able to list out the members of each of the clusters. So from that clusters, you select some sample clusters. How do you select? Here also, from among the different clusters, you will be selecting some clusters of your choice. There also non-probability sampling is there, bias is there, preference is there. So the first stage, we are making the clusters according to the priorities or preferences of the particular investigator. Then second stage, after identifying the cluster, then we are collecting the data under probability method by means of identifying the population of each cluster, defining or mentioning the members of each cluster, and identifying the sample of each cluster. Then you determine the fixed interval of the sample by dividing the cluster population divided by cluster sample, get that interval, then accordingly collect the data. So here also we are following the systematic scientific probability method of collecting the data by following a fixed interval method after grouping the whole population to different clusters due to the inability that the researcher or the investigator is not able to list out the members of all the population. But at the same time, we can list out the members of selected clusters. We can select the cluster only when we are having the idea that all the members of each cluster is well defined. It is well defined or numbered or named. Then only we may be able to select that particular cluster Determine the sample size by the usual method, determine the fixed interval method, then determine the selection of the number of items from each clusters. So that is called the cluster sampling method. Then the fifth one is called multi-stage sampling method. Usually, this is the probability method followed in most of the research works in social science, especially in commerce and management studies. And here what we are doing is the sample selection will be completed by means of undergoing different steps, different stages. Stage 1, stage 2, stage 3. An iterative step will be there. Step 1, step 2, step 3, like that. Am I audible to you? Can you hear me and see
Yes,
the?
sir.
Yes.
Yes. Okay. So we
Yes,
have
sir.
to pass through different stages. For example, if you carry out a study with respect to the consumer behavior towards luxury goods, suppose this is a research topic, consumer behavior towards luxury groups, we may not be able to get a correct picture of the consumers throughout the state of using luxury goods. Therefore, the research scholar will come to the conclusion that the whole consumers belonging to the state may be grouped into three zones, three regions: central region, southern region, northern region. This is one stage. Then, from each of these regions, we will be selecting one district, and that district is also selected on the basis of the priorities or preference of the investigator. Again, from that particular district, you can identify different municipalities or corporations or panchayat. And from that particular corporations or panchayat or municipalities, again you are identifying your own choice of selecting a corporation having higher income. And these are the different stages, different steps, multi-stage, more than 2 stages are involved. Says dividing the state into 3 regions, again selecting each district from the state, again from each district we are selecting corporations or panchayat, again from that panchayat you may be selecting a ward, and again from the ward, if you are able to list out the people who are using the luxury goods, if you are able to get an exhaustive list of the people who are using the luxury goods, then only you may be able to adopt the probability method. Otherwise, you cannot. Therefore, usually these methods, multi-stage random sampling, is also called as a complex method of probability, as it involves two types. That is, there is an integration or mixing of two methods, one non-probability method and the two probability method. So that is the next method, that is multi-stage random sampling method. So far we have seen the important probability methods of sample selection: simple random method, then systematic sampling method, then cluster sampling, then stratified random sampling. So we have seen different methods of probability methods. Now we come to the non-probability sampling methods. So determination of the samples technique is one of the important factors that will influence the genuineness or correctness of the inference we obtained the sample study. And we have seen that the inference we obtain from the probability sampling methods, the sample error will be comparatively less. If we happen to select the sample under any of the probability sampling method, the sample statistic value which we obtain from the computations after analysis may be the very same, or maybe very slowly, or very, say, very fewly deviated from the population parameter. That means the error or difference between these two values are less. Therefore, in order to have a lower standard error, it is always better to have the population sampling method. And not only that, the inference obtained from this population, these probability sampling methods can be correctly considered as the inference coming out of the population study. Now we come to the other part, that is a non-probability sampling techniques. So the non-probability sampling techniques, one is called, say, purposive sampling, or say deliberate sampling, or sometimes called judgment sampling. The second one is called convenient sampling. Third one is called snowball sampling. And fourth one, quota sampling. What is purposive or deliberate or judgment sampling? So here the investigator has his own intentions, his own interest. He need to select those respondents of his own choice. He may be selecting customers of higher income groups, or he may be selecting customers of an elite group. So he is purposive. He has a judgment that the persons who are having higher income is to be invariably included in the sample. He has selected the data willfully, intentionally, deliberately. This is called as purposive sampling or deliberate or judgment sampling. Here, no systematic sampling method is followed to identify the sample. How the sample is identified? According to his whims and pleasure. And which sample selected? According to his pleasure and interest. Now the speciality or the peculiarity is that any inference or outcome or conclusion which we reach by collecting data from such deliberate customers may not be applicable to the population it belongs to. What we can come to the inference is that this is the inference we obtained from the sample we collected. That is not applicable to the rest of the sample. That is not applicable to the population. This is applicable only to the sample from whom we made the inference. This is the purposive sampling or deliberate sampling or judgment sampling. Then another one is called convenient sampling. Here, convenient sampling means the particular researcher or the investigator has no hidden agenda. He is not biased. He has no personal biases or preferences or intentions, but to carry out the investigation very quickly, very easily, without much hard work, without much effort. We have to get it easily. So we are collecting data from those respondents who are accessible to him. If you are going to collect the data from the consumers of luxury goods, he may visit a nearby shop and find out a customer and asking us to, do you purchase luxury goods? Yes. Collecting data from him. This is nearest consumer may be selected. So very convenient. So this research is called as, say, purposive. This called say research may be of two types, maybe objective research and subjective research. If you are carrying out the research work with a way to fulfill the objective systematically, this is called objective research. On the other hand, if we carry out the research work with a way to fulfill the objectives according to the convenience of the researcher, this is called say subjective research. So the convenient sampling is one of the methods of sampling that can be adopted. Because if the population is not definite, if the population is not well defined, we can select the sample according to convenience, but the reliability or the inference or correctness or genuineness of the inference of the result cannot be applied to the population. The third one is called snowball sampling. See, snowball sampling means usually this type of sampling will be adopted in exploratory research work. Exploratory research work. First time a research work is being carried out. No studies have so far been made with respect to the area of our study. This is called, say, exploratory study. In this exploratory study, we don't have any idea as to who are the respondents expected to give the data, to whom we have to contact, how can we contact them. We may not have any database, we don't have any data source, we don't have any access to the respondents who are expected to provide information to the topic of our research. Somehow, by trial and error and by repeated inquiries, we may be able to meet one respondent and collecting the data from him. And after collecting data from him, we'll be inquiring as to him, do you know any other persons of this type? So from his support or recommendation or reference, we are going to meet the other respondent. And in this way, we may be collecting the data in the form of reference, referring or using the reference of the respondent provided the data. And this is called as the snowball sampling. So at the initial time of research work of an innovative or maiden topic, we are justified with the snowball sampling, or otherwise we can say that we cannot carry out the research work under probability sampling method. This is the ideal method of selecting sample whenever we are doing exploratory research on innovative topic on which the research is being doing for the first time. We are following the snowball sampling. Then the last method coming under the non-probability sampling method is quota sampling. So usually in research, this quota sampling is not applied. It is in consumer research and business, not for doing PhD work. It is in business research or consumer research, this type of quota sampling is used when the time frame of doing the research or investigation is less and the research budget is very, very less, and the accuracy of the survey is not having very much importance. So in this situation, we may carry out business research or consumer research under quota sampling. Say, for example, a company has to recruit the employees before March 15th. So it does not have that much time. Therefore, they will be arranging an interview from among those who are having the access to them, then making an ad hoc arrangement of interview and collecting the data from them, or screening them, collecting the data. In this way, we may make quota sampling. Or when we introduce a particular product into the market, product launching initiative is there. It is to be launched in a particular area. So he may be selecting the, say, certain number of customers, say 10 customers or 15 customers will be selected as a quota and making an inquiry and giving the report. This is called quota sampling, but this quota sampling is not applicable to the research work for getting PhD. Now we are coming to the starting point as I told you that, say, in population study, there is no ambiguity, there is no mistake, there is no error. The result we obtained is 100% is right, because we met each and every member of the population, collected the data, made all the calculations and computations systematically, and reported these are the findings, and that is applicable to the whole population. But when the population is definite, social science itself tells us that we need not carry out the census study, because much of the efforts, time, and resources of different types can be minimized if you are applying the sample study. So accordingly, we'll be applying sample study. So that sampling study can be carried out under probability method sampling or non-probability sampling method. If we carry out the probability sampling method, then the result will be more or less same as that of the population. Still, there may be difference between the population result and the sample result. So the difference between the investigation result of the population study and the sample study is called as a sampling error. If we carry out a population study, there is no question of any sample error or sampling error. That sampling error or sample error will be there only in the sample study, because we may be selecting different samples. One researcher may select 100 samples. Another researcher may select yet another 100 samples. So the sample statistics shown by the two researchers may be different. This difference in the outcome of the two samples is called as a sampling fluctuations. First sample has given a result, second sample has given another result. This difference is called sampling fluctuations. Fluctuations or changes in the results arising out of the different samples selected for the study. Or in short, we can say that a standard error, a sample error or a sampling error is nothing other than the difference between the result of a population study and a sample study. Or in terms of numerical expression, we can say that the sample error is nothing other than the difference between the population parameter and sample statistic. As I told you, the population parameter is 1. Population mean mu. The corresponding sample statistic or sample is x bar, arithmetic mean. So there may be difference between the value of population mean mu and sample arithmetic mean x bar. This difference between these two is called as a sample error. There may be difference between the population parameter p and the sample parameter small p. The difference between these two values is called as a sample error. Or there may be difference between the population parameter sigma and the sample statistics standard deviation. Yes, difference between this population parameter and sample standard deviation is called as a sample error. Or there may be difference between the population coefficient correlation and the sample correlation coefficient. These differences is called as a standard error. That is called a sampling error. And this sampling error may arise due to number of reasons. Different reasons may be leading to have the sample error. Even though we carry out the most scientific methods, there may be sample error. Because, say for example, according to the fixed interval system, we have identified the interval and we have selected samples. Accordingly, found the first item, 40th item. Next item, see, 40 plus 50, 90th item. We have identified an employee, given him the number 90. When we reached for collection of data on a particular day, that employee was not present there. He was on absent. What we can do? What we can do is we can select another 91. So we may be forced to substitute the sample. We may be forced to have non-responses also. If you approach the population having the number 90 an employee, we approach for collection of data, he hesitated to give the data. So non-response may be there, non-availability may be there, or any other reasons may be there to have the difference. Therefore, what is the sample we originally intended to select is been not obtained, on account of which there may be errors. And again, another important reason for error may be, see, with respect to stratified random sampling, see, the stratification is made by the intentional preference of the investigator researcher. He may be wrong with respect to stratification. The cluster sampling is also adopted by the investigator. The researcher may have followed a wrong clustering principle. This wrong clustering principle will also lead to have the wrong selection of items. So these things may be leading to have the sampling error, and therefore we have a responsibility of measuring the sample error and reducing the sampling error. Can you see this slide, how to measure and reduce standard error?
Yes, sir. Yes,
Can
sir.
you see the slide?
Sorry.
So this sampling error may be technically called as a standard error. The sampling error is technically called as a, or quantitatively represented, sampling error is quantitatively represented as standard error. And the standard error is numerically computed by a formula, standard deviation divided by root of n, square root of n. So if we are taking larger number of items as sample, the standard error will be less. Means larger number of sample items will be giving lower value standard deviation, and accordingly the value standard error can be minimized. Therefore, in order to have a reduction in standard error, that is sample error, it is better to have a larger number of sample sizes. Larger number of sample sizes will be giving us to have a lower standard error or sampling error, and a lower sample size will be giving a larger sample error. For example, I'm not going to work out it. See, if the sample is 40, see, we are given the information. If a company has 4,000 employees with a mean wage of 4,800 and standard deviation of 1,200, standard error will vary when the sample size equals. If the sample size is 40, then standard error is equivalent to, say, 118.87. If the, say, sample size is 100, then standard error equals, say, 100. If the sample size is 180, the standard error is 89.42. See, when the sample size was 40, error was 189. When the sample size was 100, error was 100. When the sample size was 180, error reduced to 18.42. Therefore, we can say that the sample size is negatively or inversely correlated with the standard error. That means more the sample size means lower the standard error is. This principle, this is being based on the principle of law of large number of inertia. That means it is better to have a larger number of sample items in order to reduce the difference between the population parameter and sample statistic. In other way, we can say that in order to have a lower sample error or sampling error or symbolically standard error, it is better to have a larger number of sample items. See, besides the sampling error or sample error, there can be non-sampling error also. Even though sampling is perfect, we may come across error at the time of the computation, or at the time of, say, enumeration, or at the time of writing, or at the time of making the questionnaire, or at the time of framing the questionnaire, or at the time of entering the response of the respondents, or by means of using, say, inaccurate or not non-proper statistical measures, or there can be mistakes at any stage of the execution of the work. So that type of errors or mistake which may come across during the stage of work, but not due to the sampling method, may take at any stage of the work. Say it may be on account of selecting wrong sample units. Say, for example, you are taking the response of this class from those students who didn't attend the class. So the sample unit selected is faulty. The sample survey may not be completed in time. So on account of larger number of reasons, there can be non-sampling error also. And again, I told you at the beginning itself that it is highly necessary to fix what is the sample size required to carry out the research work. The sample size should not be too high or too less. If the sample size selected is too high, it means more amount, more effort, more time, more resources being spent, and that won't give much favorable result also. But if the sample selected is too less, then we can find that the results obtained may not be reliable at all. The results obtained from the small sample study will not give the result of the population study. Therefore, it is highly essential to determine the sample size properly. There are a number of factors that determine the sample size. So, nature of universe is there. Then how many groups or subgroups are to be made within the study itself? When we collect the data, we may collect the data from the consumers. Again, we may be classifying the consumers into different strata as to high income group, low income group, or say customers who are having say behavior of purchasing say luxurious goods like that. So the number of divisions or subdivisions or groups to be made within the sample we selected is more, means larger number of sample size is needed. Then what type of sample we are applying, and what is the accuracy which we expect? What is the level of accuracy we expect? We may expect different types of say accuracy level. We may expect 100% accuracy level. We may expect 95% accuracy level. The level of accuracy expected is also an important factor that will determine the sample size. More the level of accuracy expected means more will be the sample size. Lower the accuracy expected means lower will be the sample size. See, in hypothesis testing, we are aware of the terminology that is level of significance. Level of significance is there. So whenever we are fixing a sample size, we need to fix a confidence interval level in advance. What is the confidence level with which the result of the sample study or research work is applicable to the population is to be determined in advance. Accordingly, in hypothesis testing, we have know that there are 5% level of significance, 10% level of significance, and 1% level of significance. So that level of significance is represented by what is called alpha. Therefore, what is the confidence level of the result of the analysis or the research work is determined by 1 minus A. 1 minus A. 1 means 100%. A means alpha, level of significance. Level of significance 5%. That means out of 100 results we carry out, out of 100 works we carried out, the results of 5 works are wrong, are not applicable. There is mistake, there is error. So in that way, in this particular sample size determination, we have to estimate in advance as to what is the confidence level expected from the study. What is the level of accuracy with which the result of the study is to be given to us? Therefore, we need to have a value of confidence coefficient. That value of confidence coefficient is called as ZA. ZA, or if the large sample it is ZA, in small sample it is TA. If the confidence level expected is 80%, value of confidence coefficient is 1.28. If confidence level is 90%, it is 1.64. If the confidence level is 95%, it is 1.96. If the confidence level is 98%, it is 2.33. If the confidence level is 99%, value of confidence level is 2.58. Therefore, we can find that if the confidence level required is more, we need to have more sample size. Higher the sample size means more the confidence level is. More the confidence level means the margin of error is less. And leaving this construction, the margin of error is less. More the confidence level means the margin of error is less. So margin of error indicates the precision, the correctness, to what extent there can have a difference between the sample result we obtained and the population result. What is the difference between, say, sample statistic and population parameter. A low margin of error indicates higher confidence level. So error is the difference between population parameter and sample statistic. What is the expected error? What is the expected error we are ready to afford with? It may be, say, for example, maybe 15, maybe 10, maybe 20, like that. If the error is 10, then the number of samples required will be more than the error is 15, than the error is 20. Therefore, we can find that a lower margin of error leads to higher confidence level, and a higher margin of level leads to lower confidence level. So margin of error and confidence level are inversely related. A larger sample size will increase the confidence level. Also, a larger sample size will reduce the margin of error. So if that particular error is not fixed in advance, we may not proceed further. Therefore, in determining the sample size, we have to have the understanding of three important factors. Even though number of factors are there, three important factors we have to concentrate in determining the sample size. One is called the standard deviation, or sigma. Second is called the confidence level. The confidence level is called the coefficient of the confidence level, or that is called the confidence level ZA. And the last one is margin of error. Three important factors are to be considered while you decide what is the ideal size required for this sample. One is the standard deviation, other is the confidence level, and third one is the margin of error. So by using these three important determinants, we can determine the sample size, and accordingly sample size can be obtained by the simple equation: standard deviation into confidence level coefficient divided by expected value the whole square, that is expected error the whole square. Or say we can say that that error is equivalent to standard coefficient into standard error. So I given a problem also, it to constrain the term. I'm not explaining that. One thing we can ensure is that, say, if this, say, error is, and error in the estimated mean durability article is 15. If the error is 15, confidence level will be higher, sample size will be higher. If the error expected is 20, confidence level will be less, and the sample size will also be less. Suppose the error is 15 hours, the sample size worked out is 354. That means we have to select 354 items as the sample. On the other hand, if the error is 20 hours, we need to select the sample only 199. So with which I am finishing this probability method. So it's a time for discussion. So I invite your queries and clarifications.
Participants can ask.
Yes, plus, so I given 10 minutes time, 10 or 15 or any time you discuss with and get the clarification. Otherwise, I cannot ensure that this session is, say, useful to the participants. The effectiveness of the session can be understood only from the, say, response of the participants. So I invite your queries and clarifications. Because the say in really speaking, when we carry out the research work, majority of the researchers claim that they have adopted the stratified random sampling method or cluster sampling method or systematic random sampling method. And when we ask us to, can you please explain what is the method you adopted for selecting the sample under stratified random sampling method, they explain the stratification, but they are not able to tell how I could pick out a particular sample. That is not being clear are not able to clear by the respondents or research scholars even at the time of their open defense. So I have given focus to that point of clarity. So by keeping that point in your mind, you please raise your queries and clarifications.
Hello, sir.
Yes.
Sir, my name is Amrita Ambiga. I'm a research scholar from SD College itself. So my doubt is, sir, what is this area sampling?
Ah, okay.
Is it another name of cluster sampling or
Yes,
a
yes.
form of cluster sampling?
Okay, yes. So areas, sometimes cluster sampling may be considered as area sampling also, because these clusters will be concentrated on specific areas. For example, we need to study the investment pattern of Adivasis in Kerala. We can find that Adivasis are spread over Kerala, but we may not be able to see that the concentration or the focus of Adivasis throughout the Kerala is not equal. It is being specifically concentrated in a particular pocket, in a particular area. Therefore, that particular cluster study concentrated to a particular geographical area or place can be designated as area sampling. Hence, we can say that cluster sampling may sometimes be designated as area sampling, provided there are clusters at particular specific areas or places. That is why cluster sampling in some way designated as area sampling also. So without the focus or concentration of that particular area or say location, we cannot frame cluster. That is why we may call it as it's an extension of cluster area, maybe call it as area sampling also.
Thank you, sir.
Yes, you have time again. Time is there. Don't worry. You can ask doubts. You have to ask questions. Danny, do you have any questions? Danny, the convener, student coordinator.
Sir, there is a question in the chat box
That I couldn't
that
see. First of all, let us.
what is the difference between cluster and a strata? I think it is strata.
Strata. Okay. Cluster and strata. Yes. See, stratified sampling will be used when we find that the population is not homogeneous. We can find that is homogeneous. As I told you, see, all the participants of this orientation may be considered as a homogeneous group, as all of you are attended it. It's a homogeneous group. And again, I may not be satisfied with this homogeneous. I may be come to the inference that there are research scholars who are teachers in government colleges. There are research scholars who are teachers in aided colleges. There are full-time research scholars, part-time research scholars, JRF fellows, NET fellows, PhD entrance fellows. So I may come to the inference that no, it is not homogeneous, it is heterogeneous. So if that is heterogeneous, I will be classifying each heterogeneous group as a particular group, because the group having the same property, say JRF fellows alone, one group, one strata, or government college research college, government college teachers as research scholars, another strata. In this way, we may make strata. This is called a stratified random sampling. Then say cluster. See, cluster means usually there will be concentration at certain areas. You may find that the government of Kerala has introduced a concept of cluster colleges. There is colleges or government colleges or autonomous colleges or self-financing colleges or say aided colleges working in a particular jurisdiction area can be considered as a cluster. So it is up to the researcher or the investigator as to whether that group is to be considered as a cluster or whether that group is to be considered as a strata. Both the clustering process and the stratification process is not a probability method. It's a non-probability method. It is based on the understanding or awareness or knowledge or expertise or biases or preferences or knowledge of the investigator as to whether it should be considered as a cluster or whether it should be considered as a stratum. Depends on the area, depends on the topic, depends on the relevance, depends on the concept and mindset and attitude and intelligence of the researcher or the investigator. We can consider as a stratum or cluster. But with respect to the areas, it will be better to form it as cluster rather than strata, but they are interchangeably used. I think it's clear, Soju.
Yes, sir. Yes. Sir, one more question.
Yeah.
What is chunk in sampling?
Chunk in
Chunk.
sample.
CHUNK.
So which I have to refer. I cannot answer right now. Because just, do you know the meaning of the word chunk? CHUNK, chunk. That means, say the meaning is that, even though I am not very specific with the word chunk, so we are not following the sampling in a scientific way. Whenever we are able to collect the samples by visiting a particular place where a gathering is there, we are able to collect the data without much effort. Without following the scientific systematic method, we are collecting the data just for namesake. As the respondents were available in a single place, I could collect it. So for the time being, I may be able to give only this answer. Otherwise, I have to refer it as to what is chunking sampling. That will let
Thank
you.
you, sir. There is also one more question in the
Yes.
chat box. Sir, give
Yes.
an idea about a standard error.
Standard error, yes.
We have already covered.
Standard error. So standard error means, in fact, whenever we carry out the sample study, we cannot expect 100% accuracy as that of the population. If we carry out a population study by selecting all the units of the population, we can ensure the result as 100%. But whenever we are not making use of the census study, means we are selecting only a part of the sample, the result or the answer we obtained from the sample study may not reflect the same as that of the result of the population study. This difference is called as a sampling error. And this sampling error or sample error is measured in terms of what is called the standard error. We know the standard error is determined on the basis of two factors. One is the standard deviation, and second is the number of sample items selected. So if we are, say, with respect to what we called as a descriptive statistics, we know descriptive statistics. Arithmetic mean is there, standard deviation is there. Whenever arithmetic mean is 50 and standard, say, deviation is 5, and for another sample, whenever the standard deviation is 45 and when the arithmetic mean is 45 and standard deviation is 5, there is a question arises as to which distribution is more reliable, which distribution is better. So one arithmetic mean is 50, standard deviation is 5. Another arithmetic mean is 45, standard deviation is 5. So here, which distribution is more relevant, more consistent, or say what is called more systematic or scientific? The variation or the fluctuations from the average is called standard deviation. Whenever we represent a sample distribution with the help of a sample statistic, we make use of a standard deviation. Arithmetic mean. And it doesn't mean that this arithmetic mean value is the same for all the items of the sample. Therefore, the sample statistic we computed as the arithmetic mean of the sample may be different from the individual arithmetic mean. So that deviation between the sample statistic and sample of each of the item is measured as standard deviation. So when the standard deviation is more, then we may say that there is much variation, there is much fluctuation, there is much error, there is much mistake. Here also, arithmetic mean is 50, standard deviation is 5. Another one, arithmetic mean is 45, standard deviation is 5. Which one we will be preferring? We will be preferring the first one. That is, arithmetic mean is 50, standard deviation is 5. Here, arithmetic is only 45, standard deviation is 5. What does it mean? On an average, the average value is 50. There is expected an average of plus or minus 5. This is called the X bar plus or minus standard error. The estimator, interval estimator is to be computed that I have ignored. That is X bar plus or minus standard error is there. So standard error is nothing other than measuring the applicability or reliability or dependability of the results we obtained through averages or correlations or any other means.
Thank you, sir. Sir, one more question from myself. Sir, what is the difference between multi-stage sampling and multi-phase sampling? Is both same or different? Multi-stage and
Multi-phase and multi-stage both are same. Interchangeable terminologies are used. Instead of stage, we use phase. That's so. PHASE phase, is it? PHASE phase.
Yes, sir, but some textbooks there is some distinctions are seen that way.
What is the distinction you are say identified? Multi-phase or multi-stage? What the difference?
When I read, I find it both same. That is why I asked. When I read it, I find it both same.
Both seems to be same. In research work, multi-phase and multi-stage will be the very same.
Okay, thank you, sir.
Yes. Any other doubts?
Sir, one last question. What is the difference between sampling units and sampling frame?
Okay. See, sampling units. Say in this particular orientation, now there are 41 participants are there. It will be 41. Each of the 41 participant is a sample unit. Soju is a sample unit. Danny is a sample unit. Sumi is a sample unit. Why? Because it is from the Sanesh is also there. It is from the sample unit we are collecting the data. Here, sampling frame means we have the ready-made list of all the sample units. I have the list of all the 41 participants. I can distinguish one sample unit from another one. Vishnu is different from Sumesh, or say Jibil is different from Sumi. Like that, we can distinguish. That distinction is possible in the case of the first one. But in the case of this particular, say distinction is possible in sampling unit, in sampling method or sampling frame. Means sampling frame gives the list of 1, 2, 3 up to 41. Each of the member, each of the student or scholar is a sample unit. In other words, collection of the sample unit is called a sampling frame. Collection of sample unit. All the 41 participants together is called a sampling frame. One participant alone is called a sample unit. If we put together all the sampling units, this is called a sampling frame. Yes, again, another question is difference between
the difference between multi-stage and multi-stage stratified sampling method.
Multi-stage stratified random sampling method. So in multi-stage, stratification may not be there. We are not stratifying on the basis of, say, heterogeneity. We are not grouping. But in multi-stage stratified, we are grouping it. We are on the basis of the say for multi-stage. Say for example, you are 40 students have been screened and selected for this particular, say, orientation program. So this program selected 40 students, and this selection process comprises of different stages: inviting the application, screening the application, giving the communication, and giving the link. 4 stages are there. Okay, it's called multi-stage. But multi-stratified sampling means first they have screened out the application and divide the whole application to different strata. One group from JRF fellow, one group from NET fellows, one group from PhD entrance fellow, one group from full-time research scholars, another group from part-time research scholars, one group from government college teachers, another group from aided college teachers. Now here multi-stage is there, at the same time stratification is also there, grouping on the basis of common features or specialities. That is the difference between multi-stage and multi-stratified sampling. Multi-stage does not lead to have a stratification, but multi-stage stratified sampling will have a different stratification. But that stratification is influenced by the personal bias. Why? Because it is a non-probability sampling method. Yes, any other doubts, please?
If there is no question, we shall proceed to the final session, sir.
It's up to you to decide. Krishan sir is there. Krishan sir can decide. You can decide.
Yes,
if there
yes,
is no
yes.
other question, we can conclude.
Yes, if there are no other questions, then we can go to the winding up session.
Okay, first of all, thank you so much, sir, for the content-rich session. And now I invite Srimati Shafina Ali, Research Scholar, Department of Commerce, SD College, Alappuzha, to deliver the vote of thanks.
Good afternoon to all of you. Here, I would like to present the vote of thanks in this wonderful occasion. First of all, I would like to express my sincere gratitude to our eminent resource person, Dr. B. Johnson, HOD, Department of Commerce and Management Studies, University of Calicut. There is a wonderful session. You gave a detailed picture and clear idea about the sampling and sampling procedure. We are sure about it's very useful to our research journey, and we are very happy to hear this session. So thank you so much, sir, for your valuable information. Next, I would like to express my sincere gratitude to our HOD, Dr. Krishnan, Department of Commerce, SD College, Alappuzha. Thank you, sir, for your immense support and guidance. Next, I would like to express my thanks to all faculty members in Department of Commerce, SD College, Alappuzha. Thank you all my teachers for your guidance and support. Finally, I would like to express a big thanks to my co-fellows and all participants because your participation is our success. Thanks to all participants, and finally, thank you so much.
Thank you very much. Before conclusion, I have a word. That is one who asked a question, chunk sampling. Chunk sampling is what I mentioned. It is not probability sampling. It is not probability sampling, but it is nothing other than convenience of the investigator. When he visit the a particular place for collection of data, if a mob is seen, if a group of people are standing there, immediately collecting data concerning the convenience only. This is called a chunk sampling. What I said was right. Okay. So thank you very much for giving me the wonderful opportunity of making a presentation on sampling. And I hope that the research scholars will make use of the particular sampling method that you have learned. So I appreciate the efforts taken by the Research and PG Department of Commerce of SD College, and I congratulate the head of the department, Dr. Krishnan, and the student coordinator, Mr. Danny. Thank you so much. Okay.
Thank you, sir.
Sir, thank you. ഞാൻ വിളിക്കാം sir.
Oh, yes.
Thank you.
Thank you.
Soju, can you just stop the recording?
Yes, sir.